Hello, everyone. This is Francesca Vigliani from Cloud Academy. Thank you for joining us for this webinar on using Python to manage video games datasets. It's great to see so many people connected from all over the world. Very exciting. Before introducing our speaker, I'd like to remind you that this webinar is being recorded and will be shared with you via email. We will also leave time for your questions, so feel free to add them in the chat box, and our expert will try to answer them during the final Q&A. Lastly, we hope you had time to set up the environment so that we can get going with the session. If you had problems, don't worry. Andrea will set up the environment on his laptop live so that you can follow his steps. Okay, I'm all done with the announcements. So without further ado, let me introduce you to our data scientist, Andrea Giusani.
Thanks, Francesca. This is Andrea Giusani, data scientist at Cloud Academy. I joined Cloud Academy in 2019, and actually I mainly focus on research and development here, and mainly on machine learning and artificial intelligence. My background is on quantity stats. In particular, I have a PhD in statistics, and my hobbies basically are related to numbers. So, having said that, I encourage you to prepare the environment that is needed for this webinar. And before going into that, I would like to also introduce the agenda for this webinar. And in particular, this is an hands-on webinar, so please mind that everything will be on live, and therefore I strongly encourage you, if you have a question, to basically pose them during the Q&A session. Otherwise, sometimes I will ask you directly if you have any, so that we can interact and try to simplify the process of Q&A. So basically, we will need to prepare the environment, and to do that, I prepare Colab environment, and that I strongly suggest for you to read this README that is available on the GitHub repository that I prepared for this webinar. And I also strongly encourage you to follow those instructions, in particular to clone the GitHub repository. And that includes the data necessary to perform the data analysis and a student template that has been prepared for you to facilitate your attendance. Hence, we will use that template during the webinar so that everything will be smoother and easier for you at the end. So, let me also tell you what is the objective of this webinar. And we are going to basically explore advanced data manipulation techniques using Python by using a very cool dataset, which is basically the video game sales dataset. And that contains information related to sales, video game sales, up to 2016. And it's quite an interesting dataset, since it contains cluster information of the sales by areas. And in particular, we will use those information to get some insights on that dataset. So by the end of this webinar, you will be able basically to understand the main functionalities of Pandas for data manipulation, plot raw data into nice looking charts in Python using a very popular library called Matplotlib, and finally, complete a data analytics pipeline for exploratory data analysis. So now the question is, how do we do that? And to perform such analysis, we use, obviously, as Francesca said at the beginning of this webinar, the Python language, and in particular, two important libraries. Matplotlib, that, as I already said, is the most important data visualization Python library, and Pandas, which is the most important data management and manipulation Python library. We recommend a basic familiarity with those two libraries, but I strongly encourage you to have an intermediate knowledge of Python if you want to successfully attend this webinar. If you don't have those prerequisites, don't worry. You will find all the details to dive into those techniques and the material in the webinar description, so that you can go in our content library and dive into the courses. So without further delay, let's go into the meat of the webinar. And in particular, what I want to set now is the environment that we are going to use during the webinar. So I strongly suggest you to basically open the GitHub repository that I will link to the webinar. You should basically see something on your on your laptop. You should see this kind of repository, and I strongly suggest you to follow those 5 points that I mentioned here. And as first, obviously, we recommend to use a Google Colab to attend this webinar. So we open a Google Colab session, and that looks like this one that you see in my screen. And we now require a couple of steps necessary to basically download the data and the template that I mentioned before to perform the analysis. So to do that, we basically need now to link the Google Colab environment to our local drive, to our Google Drive. And to do that, we use a very simple command, Python command, which use the Google library. And in particular, we import from Google Colab, from Google Drive, import Colab. And we then set this kind of path, which is basically the path that you have to you have in your local drive. If you don't remember that, basically you can find the snippet here so that you can pass inside the cell. So we run the cell, and an authentication is required, obviously, to authenticate. So we have to basically copy and paste the code that Google provides for us. And after that, your drive is mounted on the Colab environment. So now we are ready to basically copy the GitHub repository inside that environment. And to do that, we just need to copy those two instructions that I put in the GitHub repository. So we basically copy them without asking basically what is doing. If you are curious, I just let me, yes. So I forgot to mention one thing, because now I got an error since this is missing. So we need basically to create on our drive, as I mentioned here. I suggest to create a folder inside your drive, and for example, call it CIA webinar. So let's do that. I go into the local drive, and I create, as I said, a folder called CIA webinar. And then we basically need to link the Colab to that folder. Here we go. And then I strongly recommend to copy this command, which is basically a git command that basically is going to clone our repository inside the Collab environment. And once you have done that, basically you are ready to get your hands dirty, because if you now go into your local drive, into your Google Drive, sorry, and you go into CA Webinar, you see now that you have a new folder called CA Webinar Video Games Analysis, which is nothing more than the GitHub repository that we just downloaded. And we are going to use this file called Hands-on Data Analysis with Python Student Notebook. We open it using the Collab. So we open it in this way. And here we go. So now we are ready to basically work with the data and with our webinar. So let me also drive again the mount, because we had changed the file. So again, we drive the mount, content drive here. Again, authentication. And you just copy and paste the code. So I hope you have followed my instruction. They are pretty clear, I had to say, on the README. So I hope we are on the same page at this time. So as I said, the webinar is based mostly on two very important Python libraries. One is called Pandas and one is Matplotlib. So we import them. Typically, we import a submodule of Matplotlib called PyPlot, and we import using the acronym PLT. And we also import Pandas as PD. We also set these basically options that are necessary for us to display the data in a better way. And I decided to structure this hands-on webinar in six major sections. The first one is called data manipulation and cleaning, since many people think that data science is just about modeling and machine learning, but most of the time a data scientist has to spend his time, daily job, in cleaning data. And therefore, before going into the data, we have to be sure that our data is consistent, and in particular clean from possible mistakes and errors. So to do that, we firstly ingest the data, and to do so, we use the Pandas read CSV function, and we store the data, the CSV file, into the variable data. So again, to do that, we use the read CSV function, and the read CSV function basically requires one argument, which is a string containing the path to the data. I recommend, if you're using a Collab environment, to get that file path in this way. You go here on the top left of your browser, you select the drive folder, and you navigate throughout all the possible folders that you have. Remember that we store the data inside the CA Webinar Video Games folder. And once you are there, you see here the data folder, and we just need to copy the path to this file. So I just copy and paste inside this cell, and I just run that. Once you run that, you can access, for instance, to the first 5 rows of the dataset by using the head method. And if you run the head method, you see now a data frame that has been shown in your on your notebook, and basically you can get an understanding of mostly of the columns that make that data set. For instance, you have the name of the video game, the year in which it was published, the publisher, and a series of information related to sales, as I was mentioning at the beginning of this webinar. Sometimes it's better to get those information in a more easier way. What I mean is that the data.head method, the head method applied on the data, just returns the 5 rows. But sometimes you want to understand information like the number of rows, the type of the columns, the memory used by the data frame, and so on and so forth. So to do that, instead of using head, we just apply to data the info method. The info method is useful because it gives you an idea at a glance of what's going on the dataset. But the interesting fact is that it provides you also this non-null count column that contains basically the number of observations in your dataset that are non-null. Since you also have the total number of rows inside our dataset, it is immediate to see that some of those rows are contains null values. And for instance, those are in the platform and year column. The publisher and the year column. So that basically is a warning for us that tells us that possibly a data cleaning is needed. And that is my aim now. So we want to perform some data cleaning. And so my first action is basically to remove the null values among the publisher and the year columns. And to do that, we employ Pandas, and in particular, we are going to apply the drop NA method on that data set. So let's do that together. So I just apply on the data the drop NA method, which is a very nice function in Pandas, since it allows you to select a subset of columns and you can choose which column you can retain based on null values. So practically, this means that you have to define a subset of column, and this basically is just a list of strings, basically a list of column names. And as I said, is publisher and here. And then by default, the drop NA apply the remove of the null values in case at least one element is null. So which means that taking into account the two columns, namely publisher and year, I will remove the row if and only if at least one element is null. And that is specified by the argument how equal to any. Or if you want to be very conservative and you want to remove all the information, if basically all the information are missing, you can specify instead of any all, so that you will remove the row if and only if that is made by just null values. And I also require that the transformation is done in place. And to do that, I use the argument in place equal to true, so that the data, the null values are removed in place of the dataset. Okay, so now we have removed the data. And since the dataset was generated at the end of 2016, we can claim that any observation that shows occurrence of the year column greater than 2016 can be considered as either corrupted or incorrect. And hence it is a good practice to remove it. And to remove those information, we employ a very nice feature of Pandas, which is made by the query method. The query method basically is gonna ingest a string, which is made basically of a condition that you want to check on your data. Typically, you check the column name and a condition. So for instance, now we want to retain all the information that are characterized by year smaller than 2017. Therefore, we are going to write a string that says year smaller than 2017. As simple as that. In this way, Pandas is going to remove for us all the observation that do not match that string. Please note that you can also filter using standard Pandas the same data set using the following syntax. Sorry, smaller than 2017. So it's up to you. You can choose either to use the first one or the second one. I really like the query, so I'm gonna use that. But for your knowledge, you can obviously use also the second one. Okay, let's run the cell. Now we go to data consistency. So we have cleaned the data, but we have to be sure that the data is consistent among rows. What I mean is that typically a publisher is a string, and possibly has been inserted in the dataset by a human being, and therefore this is prone to errors and mistakes. We want to basically be sure that each single publisher has been identified consistently among all possible rows. And to do that, we now perform a little bit of data wrangling, and we want to see whether, for instance, the most important publishers are consistent within our dataset. So for instance, I would like to check whether, say, the publisher Sony was consistently identified inside our dataset. To do that, firstly, I want to basically access to all the possible identifiers that are being used inside the dataset for Sony. And for instance, to do that, we basically filter the publisher column. And since the publisher column is a string, we apply the string contains method. And we basically are going to check within the publisher the Sony string. And we also require that the argument case is false, which means that we do not care about lower and uppercase. We just need to check whether that string is contained or not in the publisher column. And we basically access directly to the publisher, again, column. And we employ the value counts to check the number of occurrences of each single publisher identifier for Sony in the dataset. If you run the cell, you see that Sony is not consistently identified in our dataset, since sometimes appears as Sony Computer Entertainment. This is possibly the most popular one, but there are sometimes identifiers that are very specific and not very popular, such as Sony Music Entertainment appears just one in our dataset, and so on and so forth. So basically, this means that the Sony publisher is not homogeneously identified among observations, and therefore we can think of basically changing those names inside a unique string, say Sony, so that we identify consistently all the observations and we don't lose basically and we don't lose it, because obviously Sony Music Entertainment is going to appear once in our data set, and therefore has a low frequency, and you can, if you don't consider it, possibly you are underestimating the Sony company as publisher. To do this, basically I created for you a method called merging information publisher that has been pre-filled for you, so we don't need to care about and programming on live on that. You will find sometimes in this webinar section pre-filled cells in this notebook. This as the reason is twofold. On the one hand, I wanted to facilitate your work. On the other hand, those methods requires a lot of reasoning, and therefore I don't want to bring too much attention to those methods, because the key focus of this webinar is to go through all the possible data management and manipulation skills and methods using Python. If you are curious, obviously, on those methods, you can ask me some question at the end of this webinar. I will be very, very happy to answer to your question. So for the moment, I'm going just through very quickly on them to give you an idea. And this method basically requires two arguments: the data, which is a Pandas data frame, and the publisher, which is a string. So at the end, we are going to filter out all from the original data set, all the rows basically that matches with the publisher string that we are passing. Here we are looking at the publisher inside the publisher column, and if that is a match, basically returns a true value, is a Boolean condition, then we replace the original string with the publisher that we decide a priori, and we return at the end the number of observations that we identified for the new publisher name. So let's try to run those cells, and in particular I will apply that method for the most important publishers: Sony, Nintendo, Ubisoft, Activision, Electronic Arts, and Konami. So we run that, and look now at if we run this cell, which is basically the same as the first that we ran in cell 10. Now Sony is uniquely identified by just one identifier, Sony. So we are consistent within our dataset. And I also add a couple of extra control for you. So for instance, we convert EA Sports to Electronic Arts using the same argument. And also we convert Namco Bandai Namco and Namco Bandai Games to just Namco. And that's it. I mean, now we have consistently identified all the publisher, and we can now check the absolute distribution of those top 20 publishers in our dataset. To do that, without no surprise, we are going to employ the value counts that we have just used. So data in position publisher is basically we are picking from the data frame, the original data frame called data, the column publisher, and we apply the value counts on that. And we retain the first 20 rows, since we are interested in just the first 20 publisher. And we get this table, which basically contains information related to the publisher and the total observation observed in our dataset for that particular publisher. But as you obviously see, now Sony, Nintendo, Konami, and other publishers are consistently identified, and so we are pretty sure that our analysis will be very, very consistent and precise with respect to the publisher column. Finally, if you pay attention, now I just retained the first 20 rows, but if you run that cell with, say, 30, you see that at the end you have this unknown publisher, which is obviously a mistake. So we want to remove that. And basically, we remove the publisher called unknown, and we store the result inside the filter data. And to do that, we basically apply the filtering based on a Boolean condition, which means that we filter the data where the publisher column is different from unknown. Unknown, sorry. Okay, and otherwise, remember that you can use also the query method by specifying publisher different, basically, from unknown. Okay, so we run this cell, and now we have our dataset that is going to be used now during the webinar, because it's clean, it's been filtered by possible mistake, and we are pretty sure that our analysis will be consistent with respect to that dataset. So before jumping into the second section, I would like to ask you if you have any question, doubt, curiosity on that particular section that we just covered. If so, you can write on the chat or on the QA question. Otherwise, you just can keep that and I will answer at the end of the section. Okay, seems not. So far so good. We now jump into the core of this webinar, and we try to understand a few insights from the data. So for instance, we want to get information from the total games released each year, which means that we want to see, basically, we want to know when the video game industry experienced a drastic development. And we can think of many ways to answer to this question. A good proxy is to employ the number of video games released each single year and use that number to basically infer the development and basically the boom on the video game industry. To do that, we are gonna basically use the filter data that we just created, and we are gonna group all the information related to the video games on the year. This is another interesting feature of Pandas, since Pandas allows easily to manipulate your data in just one line of code. So now we can create a group by method, group by with respect to the year, and counting, and based on that group by, we're gonna count the number of video games released each single year. To do that, we use the filter data that we just created. We retain two columns, namely the name of the video game and the year, and we group by with respect to the year using the group by method on Pandas. And we count the observations for each single year by applying the count method on that object. We said that we assign that object, we assign this result to the variable counter df by year. And if you try to access for instance, to the first 10 rows of this dataset, you see that now you have basically a dataset that is made of indexes identified by the year, column, and name is nothing more than the count of the observations for each single year of the column name. So here I want to stress two important facts. The first is that if you are basically working on a data analytics project, it's not very fancy to leave this column name in this way. So it's better to rename it, and we are gonna do that in a few seconds. And the second problem is that if you know how video game industry works, it is possible that a video game is released for different platforms, which means that in the same year, the same video game has been counted more than once. So since we don't want to basically count video games more than one, and therefore we don't want to introduce some bias inside our data, we perform a very simple operation that consists on removing duplicates inside our data frame. Since remember that the data frame now that we are using is filtered based on two columns, name and year, and typically a video game is identified by three columns, namely name, year, and publisher. So to do that, basically we are gonna employ the drop duplicates method. In this way, we remove all possible errors that we might insert if a video game would have been released for more than one platform. Having said that, the second control that I want to introduce is basically the renaming of the column. So I'm gonna pick the column, the data frame, and I access to the column by applying the rename method. The rename method basically allows to rename columns. And the columns argument is nothing more than a dictionary containing the column that you want to change and the column name that you wish to have in the dataset. In this case, for instance, number of games. And again, we can perform this operation in place, so I use the argument in place equal to true. And there we go. Here you see that now the name has changed from name to number of games, and we are sure by using the drop duplicates that we are considering unique values in our data frame. So now, so since you are interested in data analytics, sometimes I would say, or most of the times, you perform some analysis, you have also to translate those quantity information into a good looking chart. Embedding a data frame into a graphical dimension is always preferred since it has many advantages. Think about that if you want to share your work with your colleagues, most of them do not have a quantitative background, and therefore looking at data might be struggling for them, and therefore using a chart or is sometimes much better. But on the other hand, having all the data in a graphical dimension sometimes allows you to get a better understanding of the overall data and of the phenomenon under investigation. So now with you, I want to construct a plot using Matplotlib. I have already pre-filled a little cell here, and I want to basically translate that data frame inside a graphical dimension. And to do that, I use Matplotlib. In particular, I use the subplots method. If you know Matplotlib, you remember that Matplotlib has two interfaces, the MATLAB style interface and the object-oriented interface. The second one is the one that I'm going to use here, and therefore I use the plt.subplots method to do that, which returns typically two objects, and a figure object, which is basically a container that contains everything that you need for a figure, say the labels, the title, the legend, and so on and so forth, and the axis, which is basically the canvas where you are going to draw your data. And subplots requires many arguments. For the moment and for this webinar, we just focus on just one, the fixed size, and we set that as 12 and 10 inches, 12 for the width and 10 for the height. We also, so that initialize an object, a subplots object, and then we draw our data into the canvas by applying on the axis object the plot method, which requires at least two arguments, the x coordinate and the y coordinate. The x coordinate basically says we want to plot the time series of the number of games. On the x-axis, we are going to have the index of the data frame, namely year. And on the y-axis, the number of games. Finally, to show your plot, you have to call the show function in this way. And that is basically the result, the plain result of a simple call of Matplotlib. Obviously, you can improve that, and I want to show you at least a couple of improvements. First of all, you can add markers to the plot, to the time series, since, as you know, we are dealing with discrete count over time, and therefore we want to stress the fact that that line is not continuous, but is identified by basically singleton, and therefore by single points along the x coordinate. And the marker is, you can choose whatever you like. You can use a D for a diamond, or lowercase o for a circle. You can check the documentation online for the marker in Matplotlib, or you can check out our courses in our content library to dive into those concepts. For the moment, let's use just a diamond marker. And another interesting, I would say also cool feature is the following one. If you pay attention, the background of that figure is plain white, which is fine, but it's not, let's say, the most beautiful and awesome plot that you can think of. Matplotlib allows you to deal with some styles that are available for you in the library. And if you are curious, you can check the documentation online for the different styles. In this case, I'm going to use a style called Seaborn, which mimic the very popular library Seaborn in Python. And I want to apply that style for just this single plot. And to do that, I use the context manager in Matplotlib using this syntax, plt.style.context, and that context function requires a string, in this case Seaborn, as I said. And if you run now the cell, you see that, yes, sorry. You see now that the graph now has changed. It looks much, much better. And that was pretty easy, since we just apply with a simple with call. This is just Python, the context manager of Matplotlib, and we pass the Seaborn style. If you're curious, there are other styles like like the ggplot one. And if you use the ggplot, for instance, it changes. It's fine. Also, this one, ggplot, is a very popular library for data visualization that comes from R. And well, that is what I wanted to show to you, and that's it for the moment. So if you look exactly at this series, you see that there was a significant boom in the late 2000s, and then but you also see that nowadays the number of video games is very, very low, possibly due to the fact that both customer and developers have shrunk to converge possibly to more popular titles. And therefore, this means that possibly in the first decade of the 2000s, there was a lot of heterogeneity that now has converged to less variability and is more consistent with a few titles. Okay, so I want to move on the publisher analysis with respect to global sales. Again, this has been pre-filled for you. It's just this simple application of the drop duplicates and the group by function that we just saw. We ran that. And I want to basically now show you another graphical representation, because if we inspect the first rows, the first 5 rows of this dataset, top 10 sales, you see that now you have the publisher and the global sales. So we are not counting just the simple occurrences of video games, but we are basically weighting the publisher with respect to its global sales, regardless the year. So obviously, if you look at the data, it's quite different, since now we have categorical variables as index, and therefore we cannot use such kind of representation that we saw before as time series. And therefore, to do that, we employ bar charts. We employ bar charts, and we also have to take care of the fact that the data frame has been sorted with respect to global sales in descending order, which means from the publisher, which showed the highest number in global sales, and to the lowest one. Okay, so to do that, I basically apply again the context manager of Matplotlib, and we basically replicate the same argument as before. We use the subplots. We create a subplots object, and we apply on the axis bar h function, which requires 2 arguments, basically the x coordinate and the y coordinate. In this case, the f index and the f global sales. And then you apply basically the plt show function to show the results. Sorry, it's not the f, is top 10 sales. Sorry for that. Yes, global sales in this way. Here we go. So that plot is fine, but you can enrich and improve your data visualization skills by basically saying that you want Nintendo to be the first occurrence in this bar H chart. And to do that, we have basically to apply, to reverse the data frame so that they are the occurrences are basically we have to shift the order of our occurrences in the dataset. In this case, we are taking into account occurrences that show the highest number in global sales to the lowest. But in order to get Nintendo as first occurrence in this plot, we have to reverse that. And to do that, we basically require that we just retain all the rows and all the columns of the top 10 sales data frame, and we revert that using -1 as index. And with magic, you see now that Nintendo has reverted. So it's the first observation in the top of this chart, Electronic Arts the second, and so on and so forth. So it's much more consistent with our expectation. Okay. Let's jump into the fourth section. This is possibly the hardest part of the webinar, since it requires a lot of data wrangling from your side. And now we want to understand the most popular video game grouped by platform for each single year. So basically, we want to check which was the most popular platform for each single year. And to do that, we have to perform a little bit of data wrangling. So first, we count the number of video games by platform using the group by method, and this has been done for you in this cell that I just ran. And then we need two steps. First, we need to store inside the variable top 20 platforms, the top 20 platform with respect to the column total observation. And then we filter the data with respect to that top 20 platforms. Again, this has been done for you to facilitate the analysis. And now comes the magic, because we now have to, we have a data frame that looks like this. Okay. And remember that we have filtered the original data frame with the top 20 platform. And now we have to basically aggregate those information, since remember we are interested in getting the most popular platform for each single year with respect to the global sales. And to do that, we employ a pivot table, which is a proper method of Pandas, and it mimics basically the pivot table that are widely used in Excel, for instance. And basically, to do that in Python, we just need to apply on the data frame the pivot table, which requires a few arguments. The help here is gonna tell us which one are important. So the index, first the index, which is basically the argument that is used to set the index of our pivot table, in our case the year. The columns is an argument that specifies the columns we wish to have in our pivot table, which means that we are going to use the platform, all the possible platform inside our dataset. The values, which is nothing more than the global sales, since we want to basically check which platform show the highest number of sales for each year. And finally, we have the ag function, which is a very important function inside Pandas, since it allows you to specify the statistic on which you want to aggregate your data. In this case, we want to aggregate with respect to the sum of each of the global sales observed in each single year for each single platform. And finally, since it is possible that a platform was not observed in a specific year, say PlayStation 1 is not anymore a a valid platform, for instance. So to take into account that null values might occur, we can fill those values, those fill and a, those value with, say, a 0. And we store that result with a pivot data object. If you're curious, you can try to run that cell and run the table, the first 5 rows of the table to better understand the data by applying the head method on the pivot data. And what you see here is actually an interesting representation of your data, since you have on the x-axis the year and the platform names on the as columns. So if you instead of picking the first year, you pick the last 5 years in our data frame, you see that here you have a lot of heterogeneity, right? Because you have different platforms with that show global sales greater than 0. And therefore, you have to remember that we have to answer to a specific question, which is the following: which was the platform with the highest number of global sales for each year? So to do that, we basically have to retain the maximum value that we observe in each single row. And to do that, we use the argsort method from NumPy, which is another very popular library for matrix operation in Python. And the argsort basically is gonna take into account all the possible values that you observe in your data frame. The minus in front means that we are taking the data from the highest value to the lowest, therefore in descending order. And this function returns a list of index that represent the position of the column that show the maximum value, the second maximum value, the third maximum value, and so on and so forth. Therefore, it returns an order list of indexes that shows which column, namely which platform was the most popular one, the second one, and so on and so forth. So we run that cell, and we also pivoted data df. Okay, sorry. Let me rename it. So we run that cell. Pivoted data df does not exist. Yeah, pivoted. Sorry for that, just a typo. And finally, we apply a data frame object. We basically envelop that result in a data frame object, and we specify as index the original index of the pivot table. So by the end of this snippet, you get something that looks like this. For your knowledge, you get a table that now contains the platform names that are ordered with respect to those columns. So 0 means that is the platform with the highest highest number of global sales. 1 is basically the platform with the second highest number of global sales, and so on and so forth. Obviously, if you remember, in the first years of the 80s, just the 2,600 platform was available, and therefore just that one makes sense for us. But look at the tail. If you pick the tail of the data frame, we see that now, for instance, 2015, we have different values for different platforms. So we want to understand at a glance which was the most popular platform in that time. And therefore, using in this series of code that I show now, is just basically very simple for us to check which was the maximum number. And to do that, we apply to the pivoted data that we have in cell 50, the edmax method by specifying axis equal to 1, which means that I'm considering each single row of my data set, and I'm picking just the maximum index of that table. And we also reset the index so that at the end we get a table which will be made of 2 columns, namely year and platform, since the year now, remember, that is in the index. And we call this most popular platform by year. And we basically rename, as we did before, the columns by applying a dictionary, a Python dictionary, which requires first the column name that we wish to change and the desired one, in this case platform. And again, we make this operation in place, so we set in place equal to true. Sorry, there is a mistake, since this is not applied here, but on the pivoted data df. Sorry for that. And here we go. So we just let's access to the first 5 rows. No surprise, we get the most popular platform for that year. But again, the most interesting one is in the bottom of our data set. Remember, we want to understand at a glance which was the most popular platform, say in 2015. In 2015 was PS4, thanks to the fact that we applied the edxmax function on the pivoted data, and we retained the index that was the most popular one with respect to global sales. Okay, before jumping into the last part of this webinar, do you have any question? Okay, let's go into the last part of the webinar. So first of all, the question now that we might ask is, which was the most popular game for each single year? So I prepare a snippet for you because it's quite a long journey to produce the data set that is needed to answer to this question. So I provide the snippet here and I run the code. If you are curious and you want to get more information on that, please ask me later or just write me an email if you're curious. And all the information are available in the README of the GitHub repo, or you can contact us directly. And if you run this cell, you can get basically this table, which contains, for after a little bit of data wrangling, the most popular video games sorted for each year. And in particular, you find also information related to the millions of units related to the total sales for that particular title. And if we look at them, you see many famous titles, for instance, Pac-Man, Ghostbusters, Zelda, Super Mario World. So you see very, very popular video games. And the interesting fact about that table is that it's sorted, obviously with respect to the year in which it was published, but also with respect to the total global sales observed for that particular video game. And again, that requires a little bit of data wrangling. The code is pretty clear. because it requires the application of the pivot table that we just saw, and the application of the IDX max function that we saw a couple of minutes ago. But we haven't seen this function called concat, which is used to concatenate data frames. And the argument x is equal to 1 means that we are concatenating data frames with respect to columns. Therefore, if basically x is equal to 0 means that you pick two data frames and you append the data set one after each other. Whereas x is equal to 1 means that you append the second data frame to the first data frame by columns. And that is what we did, since we are appending the most wanted title and the total sales as different columns, populating our data frame called the most popular games. Okay, so last two efforts for us, and in particular we want to answer to two questions. First, which was the most sold title by platform? And to do that, we basically apply the merge function, which is a very other interesting function from Pandas. The concat basically concatenate two different sources of data. The merge instead is gonna apply, let's say if you are familiar with SQL, it applies basically the join that is typically used in SQL. And therefore you have to match two keys on the two different data sources so that the merge is possible. So we create basically this new object called most popular video game by platform. And this requires to join the information from the most popular games. And we also reset the index since we want the year to be a column, a proper column. And we merge with the most popular platform by year on the key that is nothing more than the year. Just a typo, and is missing. And finally, we basically group by with respect to the platform the information related to the most wanted title and to the total sales with respect to million of units, and we retain the maximum value to get the most sold title by platform. So as I said, we just pick the information related to the columns, namely platform, the columns of most wanted title, and finally, as I said, the total sales in million of units. And basically we group by with respect to the platform, as I said before, and we retain the maximum value. If you print this snippet, you see now that you get a much more compact data frame containing as index the platform name and two columns, namely most wanted title and the total sales in million of units, corresponding to the most popular title for that particular platform for that particular platform. For instance, for Nintendo, which was a very popular platform at the end of the 80s, the most sold and wanted title was The Legend of Zelda. For instance, for PS4 is GTA 5, as well as for PS3, which means that possibly that title was very, very popular on both platforms. Very interesting. But that means that, for instance, if you look at what you see that Wii Sports Resort was possibly the most sold popular game, most sold video games ever. because is the maximum number that we observe in our data frame. But if you want to get this information in a better way, and for instance, you want to get the top 10 most sold titles in the last 40 years, we can again apply a group by method with respect to the global sales. We apply also a sum method on that object, and we get basically a table which will consist on titles sorted by the global sales. Let's do that as final effort for this webinar. So we are gonna filter. We're gonna use the filter data top 20. We're just retaining information related to the top 20 publisher. Remember, and we use the information related to the name and the global sales. And we group by, as I said, with respect to the publisher. And we sum with respect to, sorry, not with publisher, but global sales. And we sum with respect to that variable. And we basically call that most wanted video game. And that object is then sorted with respect to global sales. And we apply the sort values as we did before. So by is the column on which we want to apply that that sorting. And we also specify ascending equal to false, since we want that information from the top, from the highest to the lowest. And we retain just the first 10. Here we go. So we get the first, those are the top 10 video games ever in the history. You see that the Mario games own 4 of the top 10 most popular games. It was expected, obviously. And Nintendo is possibly the most popular one, since apart from Wii Sports, you see that most of the games are related to the Nintendo platform. So here we go. So that is the end of the webinar. If you have any question, please, it's the time. So
I think, Andrea, we only have a couple of questions that we can take. When plotting the series related to the number of video games, you have added the axis labeled and a title. Is there any way to control their sizes or colors?
Okay, that's a good question, because I forgot to mention that. So it's good. Good question, since you can control both the size and the color of the basically of the labels. If you go inside those fields that we run in cell 25, if you go into set X label, you can control the size of the font of the labels, X label, by just simply writing size equal to, let's say, 15, as well as in the Y label. And the color instead is you just need to specify color equal, for instance, to orange. I don't know. Whereas for the title, you can use the font dict argument, which requires a dictionary. In particular, you have to specify, obviously, size inside here, say 15, and the color, again, we said is orange. So it's pretty easy. The logic is pretty easy. That is a good question. And if you try to run it, you see now that the font has changed and the color as well.
Perfect. We have time only for another question. Mm-hmm. Can we use the query method with the isin to create the filtered data top 20?
The filtered, okay. Let me check. The filtered data top 20. Here we go. So can you repeat the question again?
Can we use the query method with the isin to create the filtered data top 20.
Yes, that's absolutely. You can do that. So here, possibly, if I understand correctly, instead of using this syntax, which is basically standard syntax for filtering Pandas data frame in terms of Boolean, you can write this. So let me do that. Sorry. So you basically, let me create in this way a list called my list, and we apply the list method to the top 20 platform index, as we did before. And then you basically apply the query method, and you require that platform is equal to the list that you define as a global object. And to access to a global object, you use the @ symbol, as I shown here. And if I try to run these, the first 5 rows should be similar to that must be equal to that one. And that is the case because rank 1, 3, 4, 7, 8, and that is the case. So that is exactly the way in which you should do that.
Thank you, Andrea. That is it for today. So thank you again to our speaker for leading this session and to our audience. We hope you enjoyed it. And before we part, just a couple of reminders. You will receive the recording of this session as soon as it is available. And also, please fill out the end of webinar survey. Your feedback is extremely helpful in understanding what kind of webinars you'd like to see more of. Again, thank you for joining us, and until next time, goodbye.
Thank you.